Hello everyone, this is a continuation of the solve of One with the Circus. Let's continue right now. Okay, let's reset because I don't know how much my mind was clear last time I was solving this. So we'll keep the time. Okay. So again, 9 cannot be in any of these circles because there's no circle in box 1. And we know 8 of the digits at least must be in circles, and it's 38. So 9 has to be here in every spot that doesn't have a circle when it's the row, column, or box is full of circles. So 9 has to be here. 9 cannot be here in row 5, and it can't be in circles, so 9 has to be there. Let's see. 9 cannot be here or here in box 3 and can't be in circles, so it must be here, which eliminates 9 here in box 6, so 9 can only be here in box 6. Cannot be here in box 5, so it can only be here. Can't be here in box 8, so it must be here in box 8. And we have 8, 9, so the last 9 has to be here. So 8 must appear in all circles, in all boxes with circles, because it's definitely in box 9, and it can't be in a circle in box 1. So it must be 8 here, which eliminates 8 in the rest of the column. So this can't be 8 in box 7, so 8 has to be here in box 7. In box 2, 8 has to be one of these two digits, which means 8 cannot be here or here in box 5, so it must be here. That eliminates 8 from columns 5 and 6 and these cells, and it has to be a circle again where when it's not in box 1, so it must be 8 here. That means 8 has to be one of these 3. 8 must be one of these 2, which are blue or green. So therefore, 8 must be, these are blue or green. These are blue or red. So 8 is in a blue or green circle. So it cannot be in red. So 8 does have to be one of these two, which means this can't be 8 here. So all digits are going to be in circles. We have 38 of them. And that means we have 2 extra digits in circles. 7 then has to be in a circle. And it cannot be in circles in box 1. Okay, we also have 8 here. Where is 8 in row 1? Cannot be here because we have a guaranteed 8 in a circle and a guaranteed 8 in a circle in boxes 2 and 3. Can't be either of these cells because of 8 in the column, so 8 has to be here. 7 cannot be in a circle in box 1 or box 2, must be in a circle in box 9, so therefore it must be in a circle in all the other boxes. So 7's here. 7 must be here, so this is a 7-8 pair. We have 7 in one of these circles. Where is 7 in row 1? Can't be here because it's in a circle. Can't be here because it's in a circle. Can't be here because it's in a circle in column 3, so it must be in box 1. It has to be here. In box 2, it cannot be in... Why can't it be there? Technically, you could have a 7 there. Okay. So 7 can't be here, 7 can't be here. Oh, that's why, because 7 has to be there. There we go. So since 7 has to be there, 7 cannot be in box 4, cannot be here because of 7 in the columns. Can't be here because it has to be in one of these cells in box 5 in the circles. So it must be one of these two cells. So 7 cannot be here, 7 cannot be here, so 7's one of these 3, which means in box 9, it cannot be one of these because we have a 7 guaranteed in row 7 and 8, in box 8, and in box 7, which eliminates 7 in the rest of rows 7 and 8. So therefore 7 has to be one of these three. 7 cannot be any of these, so 7 has to be in a circle in box 4, so it's one of those 4. 6s. We cannot have a 6 in circle in box 1, 2, and 4, so it must be in the rest of the boxes. Therefore, this is a 6-7 pair. 6 again must be one of these digits here. And also, we know again, so 5s cannot appear in circles in box 1, 2, 4, and 7 now. So 5 has to appear in the circles in the rest of the boxes. So this must be a 5, 6, 7, 8 triplet. This can't be 8, obviously. We have a 5, 6, 7 quadruplet in row 3, so this is 1 through 4. There's no 1 here. This is 2, 3, or 4. Remaining digits in column 3 are 1 through 5. No 1 here. So we have a 2, 3, 4, 5 quadruplet in box 1. So this can't be 2, 3, 4, 5. It's 6, which eliminates 6 from being here. 5 and 6 are guaranteed to be in these cells, so 5 cannot be here either. So this is a 7, 8 pair. In box 1, we are guaranteed a 5 has to be one of these two digits, which means that 5 cannot appear in the rest of the column. So 5 or 6 or both must be in red circles. 6 has to be one of these two digits here. The rest of this box is 1 through 6, and obviously this can't be 1 or 6. So we have 2, 3, 4, 5 available. This can't be 5 because of the 5. It has to be in a circle in that box. So 4 cannot appear in circles in boxes 1, 2, 3, 4, and 7. So it must appear in circles in the rest of the boxes. So these can only be 1, 2, or 3. And we are guaranteed a 1 in a circle here in column 6. There's another 1 guaranteed in box 9, which means we have 2 1s necessary in these circles. So 1 for 2 different colors, but that leaves only 1 digit remaining that we can have in a circle because it's 38, and then 1 through 8 is 36. Now we have 1 multiple times, so it has to be, that means 1 has to be in 3 different colored circles. So that means 1 cannot be missing. So that means 2 is in 2 circles only, and it's only in column 6 and box 9. So that means any other 2 that could not be in column 6 or box 9 cannot have a 2 in a circle. So therefore 2 cannot be in a circle in box 6. So therefore that's 2, which eliminates 2 in the rest of the row. We have a guaranteed then 1 and a 3 in a circle in box 6 and box 9 and column 6. Which means if it's not in column 6, box 6, or box 9, 1 and 3 cannot appear in a circle. So 1 and 3 cannot appear in circles here or here. So therefore this is 4 through 7. This is 4 through 7. So again, 8s have to be yellow. We had this coloring here. This is a different coloring than both of these. These cannot be yellow. These cannot be yellow. So and this can't be yellow. These can't be yellow. So this has to be some combination. Whatever color this is cannot be here, and it can't be yellow either. So we had this as dark and medium and dark, right? So then this must be medium, this must be dark. These have to be orange and red in some combination. And this is basically orange and red also. Orange is the other non-red color. So we don't, that's not yellow. That's not 8, right? 6 has to be one of these two digits here, because it can't be here. Again, this is 1 through 6 here. We tried to have 7 as a red. And why did that not work? So therefore, let's just... Okay, so this has to have an 8. So one of these is yellow, which means this cannot be yellow. So this has to be red or orange. So again, if we have 7 as a red, 7 cannot be here. So 7 would have to be here, right? So we have 7 as a red. This then becomes 8. This is 7. This is 8. That's 6. 7 cannot be in a non-red circle, so it has to be in a red circle, which is only possible there. Therefore, this can't be 7 or red, because 7 has to be one of these two, and it's red, which makes this orange. 7 and 5... So 5 cannot be here, because 7 is the red one. 4 or 6 is there, which means 5 in box 5 has to be here, which means 5 cannot appear in this cell, in these cells here. So 5 also must be in this set of 3 digits, and it has to be the same color as red. So then this becomes red and is a 5-7 pair. So all the darks become red, and all the mediums become orange in that case. So then this becomes 5 and 7, which eliminates 5, 7, and the rest of the box. And this has to be 7 to be red. That makes this 6, which means this can't be 6, that's 4. So 7 eliminates 7 here, so it's 5, which makes that 7. So this can't be 7 anymore. This then has to be 7 and is red. So no orange there. This can't be red. This can't be 4 or 6. There's no more 4 available in box 8. So 6 has to be one of these two, which means this cannot be 6 here. Therefore, that forces 5 to be one of these 3. This has to be 6 because there's no other place for it in the box. This is cannot be 6 here, cannot be 6 here. This is 7, 8 as a pair, so 6 has to be here, which means this can't be 6, so that's 6 there. That means this has to be 1, 2, 3, or 5. No 2 here. This can't be red, so this is orange or yellow. So 5 cannot be there. We have 1, 2, 3 here. So far, this is turning out okay. This is red. This is orange. We have yellows here. 7 cannot be here. So 5 has to be, cannot be red here, so this is yellow or orange. 5 is one of these two. Therefore, 5 cannot be here. This is 1 through 4. Where is the contradiction here? 5 is one of these two. So this must be 1, 2, 3, or 4. This is orange. So this is red or yellow. Red or yellow here, which is why this had to be orange also. 6 is here, 6 is here. 6 can't be here, so 6 has to be one of these two. Obviously 7 can't be there anymore. Yeah, where was the contradiction here? 5 can't be either of these. No 6 here. Therefore, 6 had to be here. 4 eliminates 4 in the rest of the column. 4 is orange also. So 4 has to be one of those 3. This 2 eliminates 2 there. So this is orange. So 4 cannot be here, which is fine. And this is 4 and is orange. That's satisfied there. I mean, it's looking okay. This can't be 7, so 7 has to be there. This is 7, 8 as a pair. 5 is one of these, so this is red. One of these is red. Ah, that's right. 5 cannot appear anywhere in column 8 then anymore. 5 can't be here because of the 5-7 pair. It has to be in red, which this can't be. Can't be here, so that's the contradiction. So that's why 7 cannot be red. Long way around to get to there, but okay. So this cannot be 7 here. This is 5 and 6 then, which forces this to be a 7-8 pair. So this can't be 7 either way. This is 7-8 as a pair, therefore this cannot be orange, it's red. Because 7 and 8 are the red, yellow, orange pair, right? 7 can't be red, it's the other digit that, it's the other color that 8 is not. So this is blue-green as a pair here, guaranteed. We don't know which is which, though. This can't be 2 because of 2 in the row. 2 has to appear twice in circles. Remaining digits of box 3 are 1 through 4. It's guaranteed 2 has to be in one of these cells in box 9. And it's in a circle in column 6. We're just not sure which one. I think we marked this as A, B, and C, right? I don't know how helpful that is, but A and B have to be here. C has to be one of these 3. So A and C cannot appear here. So A and C have to be in these cells here. B has to be one of these 3 cells there. I think that just complicates things. We'll take a look at that again if we need to. So 5 and 6 are both red. This can't be red because we are guaranteed 5 and 6 must appear in box 6. That means red has to appear at least twice in box 6. If this were red, that means none of these could be red. So red would appear once in box 6 if this is red, so that can't be red. It's blue or green. This is red, so this must be yellow or orange. We are guaranteed a 5 or 6 somewhere in column 8. So red has to be one of these 2, and then the other red is here. So it's 5 or 6. Which means... Does it mean anything? No, not really. It means that whatever digit is not here has... Well, 1 could be there, right? 5 and 6. Okay, so in one of the boxes, there must be a 1 with the 5 and 6 to form 3 reds. So this is yellow-orange as a pair here, because it has to be 7 and 8. Remaining digits in this box are 1 through 6. But this can't be 5 or 6 because of 5 or 6 has to be red. No 2 here. Remaining digits in box 7 are 1 through 5. And these can't be 1 because of 1's in the column. Um, 4 could be red. It's very unlikely. So if 4 is red, let's try that. What happens if 4 is red? If 4 is red, that means these must have 2 reds here, because 4, 5, and 6 must be in red circles. So this is 4, 5, or 6. This must be 7, which means this can't be 7, so that's 7, which means this is not red. This is not orange, it's red. It's 4, 5, or 6. This is 4, 5, or 6. This then must be 6, and we have a contradiction. Because 6 has to be in red, but 7 is in orange. So that's a contradiction. So 4, therefore, cannot be red. 4 could be in yellow or orange, but we don't know which. And in fact, actually, this can never be 7. If this were 7... Oh, that's interesting. So if this were 7, that means 6 would have to be here, but we know 6 and 7 are in different circles, colors. So this cannot be 7, which means 7 has to be in dark. So dark is orange. So dark is orange and medium is red, which means this is 6, this is 5. This cannot be 5 or 6. It's 4, 7 as a pair. 6 eliminates 6 here, so that's 7, which makes this 4, which makes that 7. So this can't be 7. Therefore, 7 has to be here, which means that's not red. That's orange. This can't be orange, so this has to be 5 or 6. But we're guaranteed this can't be 4 or 5. This can't be 6. So there's no 5 or 6 here. We have a 1, 2, 3, 4 quadruplet in box 9, which eliminates 1, 3, 2, 3, 4 in the rest of the box. So this is red here. This is red. This is red. 6 has to be one of these 3, so 6 cannot be here. Whereas 6 in box 5, it has to be here. So again, 7 and 4 are both orange. This is red, so this cannot be red, which means it's orange or yellow. So 6 cannot be there. 6 is then here, and this is red. This can't be red, it's yellow or orange. This can't be red, it's yellow or orange. This 6 eliminates 6 here, so that's 5, which makes this 6. That means this can't be 6, so where is 6 in column 8? Can't be here because of 5, 6 pair. Can't be in non-red, it has to be in the red. So that's 6 there, which means this is yellow or orange. 5 has to be one of these two. Because this is 6 eliminates 6 here, so this is 5, that's 6. Therefore, 5 cannot be here, so 5 has to be only here, and it has to be red. So this is not blue, that's red. Which means this can't be 5 here, so 5 is one of these two. 4 is in orange. This could be 1 as a red. You know, 5 has to be red, so one of these is red. So this cannot be red. It cannot be orange. This has to be yellow, which 4 cannot be. So where is... We have a 1, 2, 3 triplet in box 5, which eliminates 1, 2, 3 in the rest of the box. So this has to be... One of these is red, and one of these is orange. So one of yellow, 1, 2, or 3 is yellow. It could just be 1, right? Hmm. This can't be yellow, so it's red or orange here. Obviously this can't be red. This is green. Remaining digits in box 6 are 1, 2, 3. Not 0. 1, 3, 4, 7, 8. So this has to be 1, 2, 3, 4 as a possibility, and 7 and 8 could be here, and 7 could be here. We have a 1. Okay, this 2 eliminates 2 in the rest of the column. We have a 1, 3, 4 triplet in column 7, which eliminates 1, 3, 4 in the rest of the column. So this can't be 1, 3, or 4. This is also guaranteed to be 7 or 8. One of these is 7 or 8, but we don't know which. Okay. So this digit must be the same as that. So we have that is C. And A and B are here, so this is an AB pair. Does that help us any? I don't really know. These do not have to be the same digit. If it is 4, though, it is the same digit, and it's 8. If it's not, though, we don't really have that information. Okay, orange is here, which means this can't be orange. This is yellow. So we have 2 yellows in column 6. This is yellow, so this can't be yellow here. It's orange, which means this can't be orange. That's yellow, which means this can't be yellow. That's orange, which means this can't be orange. That's yellow. Okay. So we have 2 yellows in column 6. We have 2 yellows, besides 8, I guess I should say. We have 2 yellows in column 6. We have 2 yellows in column 9. And this can't be 4. 4 has to be one of these 2. And this is orange, so this cannot be orange here, which means 4 has to be there. So 4 is here, which means this can't be 4. This can't be 4. So 4 is not here. This is blue or red. We don't know which. Hmm. 4 cannot be here. We have 4 here, and one of these is 4, and one of these is 4. So these are both yellow. This could be red here. So red as a 1 has to be... We know we have to have 1 in a red somewhere. It cannot be here. It would have to be either here, in this cell here, or here. Either way, one of these is going to be a red 1, which means this cannot be 1. It's 3. So 3 has to be in yellow. So 3 is one of these 2. This can't be 3, obviously. 3 eliminates 3 in the rest of the column. This can't be 3 either. It's 1 or 2. Hmm. Hmm. Okay, A, B, C does not seem to be helping, so let's remove those. Yeah, this has to be 3. So yellow is 3. One of these is 3. This can't be 3. What happens if this is orange? So if this is orange, that means both of these are yellow. That seems okay. Remaining digits in row 4, or row 6 are 1, 3, 4, 5, 7. Obviously, this can't be 7. This can't be 6 anymore. So where is 6 in box 4? It must be there. This can't be 1 because of 1 in the column. This can't be 1 because of 1 in the column. This can't be 5 anymore because of 5 in the row. So 5 is one of these two. This can be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 7. Okay. If 7 is here, that would mean 7 is green and 8 is blue. Okay. Seems fine. Hmm. Um. 4 eliminates 4 in the rest of column 5, and this can't be 5 either because of the rest 5 in the column 5. We have a 1, 2, 3 triplet in column 5. This can't be 1, 2, or 3. It's 6, which eliminates 6 in the rest of the box. So guaranteed a 5 in one of these two cells, and a 4 has to be one of these 3, but that doesn't tell us too much. Okay. Hmm. Um. Hmm. 1 is... Oh, this can't be 1, because 1 in row 3 has to be one of those two. Hmm. Okay. I think we might just have to try some of these, right? So we know 7 and 8 are different colors. But does that really help us any? Hmm. Um, oh, well, okay, so let's make this red. If this is red, then we know this is 1. That makes this 4. So there's no 4 there. 1 makes this 3, and we know that's yellow. So we have red 1 there, therefore this cannot be red. It's blue. So that means orange has to be not blue, orange is green. And yellow then has to be blue. Um, so, okay. This can't be 1 or 3, it's 2. So that would force this to be 3. This would be the green 1, which means this cannot be green. This would be red, so that would be 5. This would not be red, that would be green and 4. This could not longer be green, so they're both blue, and they must both be 8. So this is 7, 8, 7. So this would be 8 here. No 1, 3. This would be a 4, 7 pair, and they would both be green, so this could not be 7. This would be 7, that would be 8. No blue, no green. This would be 1, 2 as a pair. 1 eliminates 1 here, so that's 2, which makes that 1. We have a blue 1, a green 1, so that satisfies that. So this is looking kosher. So that's probably the solution path, would be my guess. So what happens if we have 1 being red here? So this is 1, which makes that 2. That means this can't be 2 here. No 1 here. 1 has to be one of... So this is 1 and 3, which makes this 2. And we have a contradiction. Because we have 2 in orange and 2 in yellow. And obviously 2 has to be part of the same color because we only have 38 circles. So therefore this cannot be the red 1. So this must be the red 1 here. So this is red 1, which makes this 3. And this is obviously yellow. That means this can't be 1 or 3. It's 2, which is yellow, which makes this 3, which makes that 1. So this is the orange 1. This cannot be orange here. It's red, which means that can't be red. So this has to be 5, and that's 4. 1 eliminates 1 here, so that's 2, which makes this 1. So this must be yellow also. So orange is here, which means neither of these can be orange. They have to be yellow, and they must be 8. Which makes this 7, which makes that 8, which makes that 7. There's no 1 or 3 here. This is 4, 7 as a pair. 4 and 7 both have to be green. So therefore, the oranges are greens. And the yellows are blue. So this cannot be blue. It's 4, 7 as a pair. This 4 eliminates possibility of 4 in a row. So this is 7. This is 4. That makes this 8 and 7. So again, this cannot be blue. This cannot be green. This can't be blue. This can't be green. This can't be blue. And the rest we should be able to do with normal Sudoku. This can't be 2. It's a 1, 3 pair. This 1, 3 eliminates 1, 3 here. So it's 2, which eliminates 2 in the rest of the row. So this has to be a 2, 5 pair here. This can't be 1, 2, or 3. It's 4, which eliminates 4 in the rest of the row. This 5 eliminates 5 here. So that's 3, which makes that 1, which makes that 7. This can't be 5. So it has to be, it can't be 1 or 3 or 4. So it's 2, which makes this 5 there, which makes this 2, which makes that 5. 3 eliminates 3 here, so it's 4, which eliminates 3 and 4 here. So that's 2. This can't be 2 or 4. It's 3. That leaves this as a 1 and this as a 3. So no 2 and 3 here. That's 4 and 5. No 2, 3 here. So this is 1, which makes this 3. 1. 3 eliminates 3 here, so it's 2. This can't be 1, 2, or 3, so it's 4. That eliminates 2 and 4 from the rest of the column. Or box, I should say. This 2 and 4 eliminates 2 and 4 here. This is 3. 1 and 3 eliminates 1 and 3 here, so it's 2. This can't be 2, 3, or 4. It's 1, which makes this 4. 3 eliminates 3 here, so it's 5 and 3. And 5 eliminates 5 here, so it's 4 and 5. And that's the solution. Apologies for the sort of the disjointed nature of this solve. I had a previous thing I needed to take care of at a certain time in my previous video, so I couldn't complete this from the end to end. It does, I mean, anytime you might be stuck on something, it's always good to basically take a step away, maybe take a break, take a day-long break, get a good night's sleep over it, and then go back, because your brain is sort of refreshed and it's not necessarily stuck in the same old patterns that you might have, right? So I find that that's the case for me, at least. It might work differently for different people. But it might be a good something that you could try if you find something that you think you almost close to solving, but you just can't seem to get there. Sometimes going away, taking a nice break, and then getting a good night's rest, and then coming back to it might make it easier for you to solve in the future. This was very cool, actually. This interaction between the colorings was very interesting, right? And then this particular interaction was very interesting. I should have been able to spot that fairly early on, I guess. Because if you make that 7, then that has to be 6, but then these have to be the same coloring, right? So that's going to be problematic. So then 7 has to be part of that coloring, which makes that also very interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.